All right, so I'm gonna do a full demo on how to write firmware for the BlueNRG. And as an example, I'm gonna use the HM11 and replicate the services and characteristics that this one offers into the NRG BlueNRG from ST. So let's look at what this one has to offer so we can replicate here. So we'll connect to the HM11, and let me bring it up on my screen so since you'll be able to see it better. Let me move this out of the way. And I lost the connection, so let me reconnect again. All right, so bear with me. Not connecting. Oh no, there it goes. Okay, so it took a while. It's connected now. So if you so this is the HM11 here, and if you look at this, is advertising the name, and it's advertising one service. We have all other ones here that they're not advertising at all, no name, just that they're there, no services. So, but they do have services. So let's look at the HM11. And aside from the name, you can see the service ID, which is 16 bits. And you can see the characteristic ID, which is 16 bits as well. The characteristic has a name, descriptor, and it has properties. It has read, write without response, and notified. So it has those three properties. So if we go and look at the detail of it, you'll see that it has these three properties. It has read, which is this one here. It has write without response, which is this one here. And it has notify, is this here. What notify is that if you listen for notifications, when the device sends data to your client, then you don't get a notification, and then you can go and read the data. So you don't have to click read or again and again, or keep polling the connection to see if you have any data coming in. Also, it has two descriptors. One, the first one is for the notified, and the second one is for the name, the user description. So we're gonna replicate this whole thing. It's gonna be a long video, so if we get time, we'll also add the actual functionality to move data back and forth between the device and the phone and the Pico and all of that. So right here, I have a rough outline of what needs to be done. Obviously, it's pseudocode per se. So it has, just the steps to get it to where to what I want to show. So let me disconnect from the phone, and let's get started. So so I'm going to start a new project. It's going to be from scratch, and we'll call it full demo. And I'm going to use the same file I downloaded on the 9 for that demo. So I'll add the link in the description where you can download this, and the channel of the person that of this template, the one I'm using. So I'm going to go here, and I'm going to copy everything except this one. That one has a lot of files that I'm not going to use anyway. So I'll just move that over. So there we have it. So step number 1 is to create the directory structure, and that is to create the library folder, the object folder, and then the C++ file structure. So it will be Cpp, and inside that folder, it will be include and the src folders. So now I can go and open this full demo. Let me move it over here. So we have visibility. So first thing we're going to do is we're going to move these files, the library files. So let's use the make file as a template, which is because this is all we're going to move. We're not going to use the make file to move the files for us. We're going to move what we need. So first, we'll move all the peripheral drivers. So we'll go to Tools, and the location of your library files are going to be different than mine. So just point to the right location. Peripherals, source, all of the files, move them over to the library folder. Then the hardware files, the clock, utility, memory functions, and then sleep. Okay. We'll move the BLE source user stack or stack user configuration. It was this one here. So now I'm going to move this one, which is the CMSIS device ST, this guy right here. And finally, we need this file. That's the only file we need. So we'll go to, what is it? The SDK eval, move this file over. So that should be it. The next thing we need to do, it's, we'll come back and do changes to this one, but the first thing I want to do is go to the settings configuration here and change the path here to the update the library path, which is this, and then update the compiler path as well, this one. Remove the ones I'm not going to use, switch the backslash to forward slash. Okay, I can save this now. Now I'll go back to my make file, and I'm gonna follow this part. So I did this change. I did it ahead of time, but I just jumped the steps. So I did this too. Now I'm gonna modify the make file to work with my structure. So because it's gonna have C++ files in a different location, I need to specify where that location is and the type of files. Okay, so that's what I need. I'm gonna also name a different variable to hold that information. And here, I need to append it to the objects variable, the CXX variable for the CPP files. I need to make the includes visible to the compiler. I will comment this line because it doesn't work on my setup. Remove this, it doesn't work on my setup either. And here, I'm gonna remove all the object files after they compile. I want a clean folder every time I compile. I want to do a clean compile, new objects. It takes a little bit longer, but it removes a lot of the bugs that you may chase that are not really bugs. They're just pre-existing in the object files. So I'll add that there. And last, we need to make sure that the C++ files are visible as well here to compile and link. So that's it on this part. Now I need to modify the settings I did. I'm gonna modify the CPP settings, which is this. And this is so when I'm coding, the IntelliSense part of the system knows where my C++ headers are coming from. So I'll add that there. Save it. I can save the make file. I'll save the settings file. I can close everything now, go to my main source file, and I'm gonna do my first compile, but first I'm gonna clear everything here, and I'm gonna just include the std, what is it, io.h, do my main function, and return 0. So we should compile, everything should be good to go. So that's our first run, right? So it compiled, you can see it here, it created this file. So if we go to bin, you'll see that we have multiple files there. So while we're adding it, let's go and update this. BlueNRG full demo, right? So I'm gonna compile again, this file is gonna pop up here. And you will see it here any minute. What happened? Oh, I didn't save it. Is it because I didn't save it? Let's try again. All right, so there it is, right? So there's the new file, there's the elf file and the bin file. So we don't need to see that. We have our folder. So the next step is to, so this is just generic stuff that I'm gonna do, but let's continue here. So we're gonna transfer control now to the C++ structure. This is still in C. So to do that, we need to, in the C++ include folder, we need to create our main header for the main function. And since this is going to be C++, we need to include this so we can do the includes and definitions inside this definitions. So, or extern C. So we'll include the, not include, but define the new main function. So if we go to main now, we should be able to include it. And we're going to do the same here and include the main CPP file so we can transfer it to the main CPP function. Even though this function does not exist yet, we're going to create it right now. So now we have the header. We need to create the source file. So main cpp.cpp. We'll add the same thing as on the other one and include what we need here and the main cpp.header. This is our main function, our main loop. So let's compile. So now when this runs, it's going to get to here and it's going to call that function, which is on the C++ side of this thing. And now we can write C++ code and it will be running here. So let's go through the motions of creating this stuff. So first we need something for debugging purposes. So we're going to create an AT class and we're going to be adding functionality as needed. So we're not going to create everything from the start. We're going to create the minimum requirement to do what we're doing at the time, and then we'll add functionality as we need to. So let's create the AT header file. So we're going to define our class here. And first we are going to include the stdio.h because we are going to need it. And then where's my structure, my template? There it is. So this is my class. And my class is going to have variables, private and public. So, and we will have functions as well. So the first one, static, is going to be an integer. Max size, this is going to be the maximum size of my buffers. We want a buffer for well, a buffer, a temp buffer or temporary buffer, right? Okay, and I'll just copy this because I'm gonna need it again on my public variable. So I need one more for my message. So we'll capture one character at a time in buffer. Once we get a full message, we'll transfer it to message, and then we'll be good to go. We need a way to tell when we have a new message. So new message false. And now we need some functions here. So for these functions, well, first let's define those functions. First is the init uart, right? We need to specify the parameters for the serial communication. Is going to be 32-bit, and it'll be for speed. We also need to add a character at a time. So it'll be C, one character at a time. And last, we want to send messages. And it will be a pointer to message, and it will take a variable number of parameters. So that's what we need. Now we need to move this item here and put it on the source file. So we'll move that, save it. Let's create a source file under src, and it'll be at.cpp. We'll put the files there. We'll add the same thing as before. Include the header file, and we'll include a bunch of header files we need. So we need the what do we need here? We need the Gpio for the UART. We need the UART as well, and I think that's all we need for those. We do need what do we need? We need the string for memory functions and the arguments. I believe that's all the ones we need. I'm not sure why this one's different color. Oh, it's because I added this at the end. All right. So let's go define our first function, which is the Init Uart. Right, and this one takes a 32-bit variable. So if we go look here, we need so to initialize, we need the system control peripheral clock. So we do need to include that. Blue system control, that one. So now we can say syscontrol. Is that the one? No. Syscontrol peripheral. Yeah, that one. So we need to initialize two clocks, one for the Gpio and one for the UART, and we enable them. Now we initialize the Gpio for serial communication, so init type, and it'll be IG. We have to specify those four what are they? Variables, parameters, whatever they are. So first, the high power, it will be disable. The mode will be serial 1 mode, and the pull-up will be disable. And finally, the pin, we have to define 8 and 11. So 8 is for outbound, 11 is for inbound, or transmitting and receiving. And so is the Gpio pin 8, right? And now we can say Gpio init the IG. We have to do the same for 11, so we copy those two, change the pin to 11. We're ready to go. Now we need to initialize the UART. So we need to execute those 5 functions, but first we need to define the structure. So UART init type, and it'll be IU.
So this one has a whole lot of parameters or properties that we need to set. So let's start with the first one on the top, and we'll set this for speed. So that's the baud rate, and the FIFO enable, the hardware flow control, none. What is this one? Oh, what was it? The mode will be the UART mode. So we have two, RX and TX, and we're going to use both of them. So UART mode text, so that's RX and TX. The next one is parity, no, and stop bits, 1. This one are 8 bits, both of them, and the next two properties. So UART word length 8 bits. Same for the next one. Now we can do this function. So the initialize init, and is the IU, and then URCMD. We're gonna enable this part, and then the UART RX. What's it? That one? We're not gonna use this one right now. This is for interrupts, but we are gonna use it later. So let's just define it now. Okay. Don't ask me what this does. I haven't looked into it. I just know it's needed when you do interrupts. So that will define the UART. The reason I have it on a separate function and not on the constructor is because we want to create multiple instances of this, but only initialize it once. So the next one is the at character, right? So it takes a character, a C, return, or C equals line feed, or what is it? Buffer counter is more or equals to max size. Then we know we have a new message. Else, we just add the character to the buffer. So buffer counter plus plus equals C. And here we can say mem copy. We're gonna move the contents of buffer into message and max size. And then we clear buffer by writing a bunch of zeros. We set the flag of new message to true, and buffer counter equals 0. Okay, so that defines our function to start adding characters. The next one is to send a message. And for this one, we need a local buffer, 100 characters. It can be any length you want. So we need to specify a variable to hold the parameters. So it's a list of arguments. And to get a start, we specify the variable and the I guess the parameter where the one before the arguments start, the number of whatever arguments it is. So in this instance is message. I don't know how to explain it, but you're just saying after this one, these are variable arguments, and you can put it there. Now we can use vs printf. So this function is the only reason why I need to add this one here, because that one has one of the functions that this one requires for it. It doesn't, otherwise it wouldn't work. In any case, so we're gonna, in local buffer, we're gonna add the formatting part of it, which is message and the arguments.
and then we end it. So now we need a loop to send one character at a time through the serial port. So index is less than str length, the local buffer. Okay. So where are we right now? So we are here on sending message, right? So we need to look at this to make sure that the FIFO is not full. So this flag is the one we're going to look, use it through this function, and then this is what we're going to use to send data. So this is where we say if UR get flag status, UR flag FF for transmitting. If it's set, that means that we can't send any data, right? So we do something here to wait. Otherwise, we send the data, and the data is in local buffer, and it will be indexed as the index to tell which character to send at a time. So how can we handle this part? Well, we can use the time. Do we have that here? I haven't included that part, so let me include the clock. Include the clock. So we'll call it time. Here we'll say time equals clock time. And here we'll say if clock time is more or equals, actually just more, then time plus half a second or 500 milliseconds. So we're gonna give it half a second before we just get out of it, saying, if in half a second the output buffer is still full, that means that there's no host connected on the other end, and there's no point in trying to send more data because it's full, and we're just gonna be stuck here. So I'll just return. So that's it. So that's that function. So now we can send messages, we can add a character, and we have a UART to initialize. So let's test that part, make sure that everything works. So we'll go to main CPP and include the add command or add class. Here we can say add, and we'll call it Pico because it's going to send to the Pico, and it will be Pico initialize UART. The speed is 115200. That's it. Here we can, well, obviously before we do that, we have to do the system init. So we need more stuff here. We need to include the Blue API and the clock as well. The clock. So now we can initialize the system, and we can initialize the clock as well. Okay. And inside the main loop, we can just pause for a second or two. Let's do 500 milliseconds, and every 500 milliseconds we'll send a message just to test this part to make sure it works. So new message, and it will go to the we'll see it on the phone on the other end. So I will let me see. All right, so there's my phone. Let me bring this up, and it connected to the HM11. So the BlueNRG or the EMB1061 is going to connect to the Pico, send the data there, and then the HM11 is listening on that same port to connect and send it back to my phone here. So let me move this over. Oops, where'd it go? So let's compile. We're still going to have some errors, so we still have to fix those errors, and then you'll see it here. So let's take care of those errors. And they're likely scripting errors. If I can find them, where is the error? So here's an error. Oh, that's a different thing. Let me see. Let me compile again to get the real error. So here we go. So that's a real error, right? So, well, is that the only one? Yeah. So let's go look at this error here. And it's complaining about this one here. All right, let's compile again. All right, so these are the scripting errors that we're going to fix. One for CXA and another one for GXX here. Make it a little bit bigger. So this one here and this one here. So to fix those, you open the LD file, go to the bottom, and if you see my previous videos, you'll know that I added the same thing over there. So you add first we're gonna add what is it, the EXIDX, right? So let me make this smaller so I can see the actual errors here. They were smaller. Make it bigger and maximize this window so I can see them properly. So is the EXIDX, and I'll paste that there. I also need one for this one that says N. Is that the one? Oh, start, sorry. So, all right, so actually let me put it before. I don't know if it matters, so I'm just gonna put it before. Okay. And is there another one? Let's compile. All right, there's more errors here. Let's see what. So now is this one here. Actually, there's an abort. I don't know if it goes there. Let me just add it there. Let's compile again. I see the GXX that I didn't take care of. So there's two more. There's this one, the EXIDN. This one doesn't belong there, so I gotta remove that there. Sorry, I got confused. So this one goes here. Is the same EXIDX. And I'm gonna add another section here for CXA. I'll move this there, and I'll move that one there. And I also believe this one goes at the bottom as well. Maybe, I'm not sure. So let's compile. All right, so it compiled, we're good to go. So we can close this. We may get more down the line as we add more stuff. But let me open first this application. This one monitors my location of the bin folder, and so as that's not what I wanted. So when it compiles, it'll pick it up and load it. So you'll see that here this is going to change when it loads. It'll find it, and then there it's updating the device. So we should see messages here if I did everything correctly. So there's the new message. It's coming up, right? So we're good so far. So we got something to debug. Now we can follow this and add the actual Bluetooth functionality. So let's get into the meat of Bluetooth now. So let's create the class. We are going to create this Bluetooth class, and it's the same process. We add a header file, and we'll call it Bluetooth header. And here we're gonna include whatever we need to include.
Actually, we don't need it here. What we need is the header definition. And we'll include the same thing as before, stdio.h. We'll define the class, the template. We'll call it Bluetooth. We're going to need a lot of handles here. So let's define what those handles are. First, let's do the address, device address. And it's going to be 6. Sorry, not, yeah, 6. So it'll be 1, 1, and we'll do 6 of the same. So that's 1, 2, 3, 4, 5, and 6. And we'll just put an A there. Actually, let's leave it on 1. Okay. We also need a device name, and we're gonna make it a maximum of 23 characters. We're gonna define it as empty. And now we define the handle. So this one's, the handles are 16-bit. Oops, 16. Let me copy that so I don't have to keep retyping it. First, the default handles is the gap service handle. Then the gap character handle. And the gap character appearance handle. Handle. Okay. So we'll come back and add more as we need it. Right now we only need those, so let's just keep it like that so it's easier to understand. So those are the things we need as far as private variables. So let's add some public functions. Actually, let's make a change here. So for the constructor, we are going to add a name. Yeah. So we'll call it name. Okay. And for these functions, so that means that I have to change this one here too. Here. Okay. So the first function, it's to what is it? Let's see. We have to initialize the device right here. Okay, hold on. Got an important message. All right. So the initialize device. We also need the at service and tick. So at service, if I can spell it, and application tick. Okay. So those are the ones we need. Let's go and initialize the device first. So we can move this out of this place. Go and create the source file. Bluetooth Cpp. So we'll include the Bluetooth header file. Move those files there. Now we can start adding the things we're going to use. Let me save this first. Okay. So we want to include the API for sure, and the system control. This one here. What else do we need? What do we need? We need constants. I don't know where they are. But we do need this. So let's move this file here. I'll figure out what else we need to add. Right now I don't remember, but we do need this one. So we're gonna move this one here, and we are going to rename it. This one holds the definitions for the database size and descriptors, attributes, and all the good stuff that is important to understand, because this is what causes the major issues. So now that we have that, we can go and first let's define this one. We'll copy
whatever that is, actually we need to clear first memset, and we're gonna do the device name, zeros, size of device name. Okay, now we can copy device name, name, the length of the name. Okay, that should be it for that one. Obviously, we need the string that each header for those functions to work. Let's do the what will be the first one? The initialize device. All right, so we need to use all of those functions, and let's just set up something to see what the return is. So it will be int8 and return. Actually, before we continue, for debugging purposes, let me go back here and add the class that we added, which is that one. Well, we also need to include it here and include the header for the add class. So we can call it serial, right? So now that we have that, we can go here and we can print stuff for debugging purposes. So first, we'll do that, and we'll call the ACI hull write configuration data. I think that's what that one is. Let me see. Yeah, so this one, configuration data, is the first one we're going to define, right? So what is this one? It requires an offset, is 0. It requires a length, is the length of the data to be written in this command, blah, blah, blah. I don't know. Is the size of the address. So the size is 6, or we can do size of device address, right? And that will give us the same result. The next one is the actual value. So the value is the address, so device address. And that's it for that function. So now we can say serial send message, and we can say, like, get configuration data. But this is pretty straightforward. We don't need to do anything here, any of this stuff on the initialization. And by the way, I wasn't supposed to put it here. I was supposed to put it here. So for initializing the device, we don't need that because all this one is just default initialization stuff. So we don't need to check anything. It's on the next one, on adding services. So the next one here is, where are we? The set power level. So ACI set, that's not it. Set transmission power 1.4. This one can transmit power up to 8 dBm. Next one, ACI get init. This one does not take any parameters. Gap init. So there's a difference, GAP versus GATT. Right, this one does take a bunch of parameters. First is the role. So let's see what that is. And let me maximize this. Put it on the side. The role we want is peripheral. So we're gonna put on 1. You can put the constants, but I'm just gonna put on 1. The next one is the privacy enable. We're gonna say 0. This is just a demo. The name, the device name character length. So is the size of device name. Okay. And then the handle. So the handle here is the gap service handle. And then the character name is the gap character handle. And finally, the appearance. So we'll do the gap that one, character appearance, and that's it. So that will get us to that function. Hold on. So next is the ACI get update character value. So get update character value extended, and I don't know what this one does, so let's open it up and do the same as before. So the first one, it takes a connection handle to notify. We're not connected to anybody. This is self-initialization, so we'll put a 0. And then the service handle is the gap service handle. And then the character, same gap, characteristic, not character. Now it wants the update type. So the update type is local update, because this is just us, so it's 0, this right here. The next one is the character length. So this would be the size of the device name, right? Then the value offset is 0. The value length, same size of device name. And then the actual value, which is the device name. And that should be it. So we're done with that function. We're good. I know we're not doing any error checking. Again, this is just a demo. So Bluetooth at services. Let's see what we need for this one. So we need to add a service, add a character or characteristic, and then add a description to that characteristic. So we need more handles for this. So let's go back to the header, and we'll add those additional handles. The first one, let me copy this. The first one will be the service handle. Second one is the characteristic handle. And last, we need a description handle. Okay? Or user description handle. You can give it any name you want, whatever makes sense to you. So now that we have those, we could specify here also the description of that. So why don't we do that? So we'll say the the description will actually be the, let's call it description. Now we'll write it on the fly. There's no point in keeping track of another variable. I have too many already. So we'll come here. First thing we want is we want the ACI get, oh, here we are going to do have something to debug it. So we can say ACI get, where are we? At service. And for this one, it requires a service ID, which is this right here, right? So we need to define that first. So first we'll say, what's it? Service UID, and we'll call it SID. We need to define those. So it will be, it is 16 bits as well. 8. Let's make it 8 so it's easier to define. So the let me go here. Actually, I need to go here and disconnect so I can see and connect again.
Right, hold on, it's connecting. Sometimes it connects quick, other times it takes a while. Let me disconnect again, try again. All right, so this one, the IDs are 16 bits. It's FFE0 and FFE1. So we'll do AAE0 and AAE1 just to keep it similar. So let's connect again. We'll go back to this and we'll say that the address here is E0 AA. So this will be for the service service ID and the chart ID or characteristic ID, and this one will be a 1. Okay. So we can say 2 and 2 is not required, but we're just going to put the 2 there. So now we can come here and do a mem copy to SID 16 bits, and we'll copy the service ID 2. So now here we can say the service ID, or actually the type is 16 bits. ID type, where is it? All right, I need to add something else here. Let me see if I know where it is. This one here, constants. So UE type 16, this one right here. And then we add the actual service. So SID. The next is the service type. I don't remember what that is, so let's go check that out, what the service type is. So it's primary, it's a 1. And let me maximize this. Put it here on the side. So it's a 1. And then it's asking for the maximum records that we're going to add. So at the beginning, we're only going to need, what is it, 4? I think it's 5. 5 attribute records, and I'm going to explain what that is later. And then the service handle is the service handle. All right, so that's it with that one. So this one here is the amount of handles that this device is going to create. Is in its one handle for this specific function, and then you need a handle. You need 2 handles per characteristic, just for the definition and declaration. And then you need 1 more handle if you specify notified, and then you need 1 more handle if you add descriptors. So we are gonna have notify on it, so that it's 2 from the beginning. Notify makes it 3, and then the descriptor is 4, and then 1 for this one, that makes it 5. Okay, so we got that out of the way, and I'll explain where you set those parameters. So that's that one. The next one, close this. And what am I going to open? This one. All right, so the next one is this one here, to the characteristic. So actually, before we do that, let's put some debugging stuff. Send message. And this one will be the service. 2x, and it will be that one, right? The return. We're going to do 3 of them. This one is the characteristic, so we can see what's going on, and this is the descriptor. So here we can do the next one, which is ACI, well, this one here. So we need, again, a service ID, right? And this will be a CID. The name doesn't matter. We're going to copy CID, the 16 bits, the variable we defined before, 2 bytes. And now we can say ACI get at characteristic. right? And for this one, it doesn't actually it requires quite a bit of stuff. So let me bring this up so we can see some of the stuff we need to add. Put it on the side. And let's start. First one, we need the service handle, right? Second, we need the type, so it's 16 bits. And then we need the CID. Now we need the length of this. So how much data do we want to send? Let's make it 20 characters. That we can send a maximum of 20 characters, but we could send less if we wanted to. But 20 is the max. And then the character properties. So the properties, this one's here. We're gonna use the notify, which is the ones they have, and then the read and the write without response, right? Permissions, we're gonna set it to none. The mask, we're not gonna set any mask right now, but we will later. Actually, we do need a mask. Let me set it right now. So the mask is gonna be the notify write, and I'll explain what that is. That one, notify attribute write. Next, we need the encryption key is always 16. Is it a variable length? Yes, it is. So we'll put a 1, meaning that we can set a maximum of 20 characters, but we could send less. So the amount of data we send could vary. And then the character handle. So that would be that one, the characteristic handle, not the character handle. And that's it. That's all we need for this one. Next, we need the this one here. So let's close this one again. And now we need to specify a character description ID structure, and we'll call it CDID. Same, mem copy, CDID on the 16 bits, and we'll call it description. I think it was description something. Let's see what it was. I think it was description ID. I don't know. Let's see. Oh, I think we said, well, let's see. I don't have it. That's because it doesn't need one. It actually, we're gonna get it from somewhere else. So the ID here is gonna be 16 bits. It's a descriptor and they're already predefined. So it's a character user description UEID is the one we're gonna use. So obviously we need to give it a name. So it'll be ID. All right, so that's what we have. We'll have to give it that, and it'll be size of 2. That one. So now we can call the right here, this one here, ACI get at this one. Okay, so let's maximize again. This one takes a lot of parameters as well, so let's see what those are. Right there. So the first one is the handle, so service handle. Then it takes a characteristic handle. Okay. Then it takes a type of 16 bits, and then the CDID. Then it takes the maximum value. The maximum value will be the size of whatever the description is. So let's create that right now. We don't have it yet. So we're going to create a variable here. And this is the description. So we'll call it description1. It will be equals guser to guser 210 at command interface. Okay. And that will be 30 characters. Right, so we have it at, well, this one doesn't have any limit, but we need to keep track of this. So we need to know that it's 30 characters long for this one, because we are going to need it down the line. So description1, and the next one is the value length. So this is the max, this is the value length. This is just in case you want to set the maximum and you want to send variable length. So it's the same thing, description1, then the actual value, description1, okay. Then the security permissions will be none, so we'll set a 0. The access permissions will be read, so we'll set a 1. And then the mask will be 0, do not notify, right? And then the encryption key, 16, like always. Almost done. So is this a variable? No, it's not, so we'll put a 0. And then we can put a 1 and it'll work. Actually, well, leave it like that. And then the characteristic handle. So now we can say the description handle, that one. And that's it. So that's pretty much it. Now the last one, just to make it work, is the Bluetooth tick. That one. Let me close this, move this to the side again. So this one should be easy to implement, is this one here. We're only going to implement this 4 at the bottom, and we'll implement this last if we get time, because the video is already going to an hour, over an hour. So we need to specify the data we're going to advertise. So first, mdata, you can name it anything you want. And we specify here the type of data we're going to advertise. So how do you know what you are going to advertise? Well, first, what type of data we're going to advertise? We're going to advertise the service, and the service type is 16 bits. So we're going to use a 3 as a flag. And then we're going to advertise the entire name. So we're going to use a 9 on the second one. And the way you do that, if we go and look at this, this is an example of how to advertise. So the first byte is the number of bytes for the first section of data you're sending, or however many sections you might be sending. So it's 2 bytes, 1 for the flag and 1 for the value. And then the next one, it says 10 bytes. This is the first one, and then there's 9 of them. So this says 10 bytes, and this is the flag that says I'm sending the name, and this is the name right after. So that's what we're going to be doing. Except instead of this one, we're going to use, instead of 1, we're going to use 3. So let's go back to the code. And so the first thing we're going to say is we're sending 3 bytes, right? And then we are sending the, what did we say we were sending? Number 3, so the list. So 0x3, or you can put 3 since it's the same thing. And now you send the 2 bytes of your service, and the service is E0, and the second byte is AA, right? And now the next one, what's the size of the next packet? The size is the size of the device name, and because you need to account for the one design specifying the size, it should be +1. And then we're going to say a 9 because we're sending the full complete local name. So the size of putting there is replacing this part here. So I'm just putting it there so it's calculated at runtime. Okay. So let's go back to the code. So now we have to say, okay, so how big is this going to be? Because this is not going to be the entire size, right? So it's going to be 1, 2, 3, 4, 5, 6 bytes
plus the size of the device name. All right, so now that we have that, we can copy the name into mdata, and we can copy the device name, and it will be the size of device name. But we have to tell it where to start, and it's after 6 bytes or after byte number 6. So now let's go back to this. Remove this a little bit. So now we need to do this HCI LE scan response. So we'll do HCI LE scan response. That's not it. Scan response data. Okay. And here it should be the, so is the size of the data you're sending, so it's whenever it's in M data, and then the data you're sending, which is M data. Okay. The next one is ACI, so now it's the application command interface as opposed to the host gap set discoverable. And here it's asking the type of advertising, so it should be advertising indirect connectable, whatever that means. I think it is 0. We'll set this to 100 and 100. This is required. So a minimum 100 to have a consistent connection. And then the on address type will be 0. The advertising filter, there's no filter. Let me go down a few. And then the local name length, that's the size of the device name. And now the actual device name. And then the we're going to put 0 here because we're not using any list, so we'll say null. We'll say 0 again, 0 as well, and that's it. The last thing we need now is just the ACI gap update advertising data, and it's the same as the first one, is the size of the M data and then M data. So that's it. Let's compile. So with all we did right now, we should be able, it's gonna fail, but we should be able to replicate the what we just did, what the HM11 does. So let me first fix these errors, then we'll go and fix the database size. Let's see how many we have. So the first one is this. This one needs to be set like that, and there's probably the next one too. Yep, right there. All right, so it's good. However, now that I just run it, so I'm gonna instantiate it and call it and see what errors we get. So first, I'm gonna remove this out of here. We have all of that. We need to include one more thing, which is this one. So we'll set to include the BLE config. So we can initialize. I don't remember what it's called, so let me go to the file itself. Go to the bottom, and we need the BlueNRG stack to initialize. So we know we need the stack then. Okay. So now that we have that, we can call the BlueNRG stack initialization, that one, and it's already defined in that same file, so we'll use that. Once we initialize, we can call it and say BT, stack tick, and then obviously we need to, well, first let me send a single message, main loop. The first message never goes for some reason, so I just need to make sure that when I start sending messages for debugging, I can get the first one by doing this. So now I can say Bluetooth I don't have it yet. I need to add it here. Okay. So Bluetooth, and we'll call it BLE, BLE Initialize Device, and then BLE at services. And if you remember when we define this, it takes a name. So let's call it GUser 210 BLE device, right? So that's what we're gonna be naming our device, or BlueNRG device. It doesn't matter. So it'll say BLE device. Actually, let's change it. BlueNRG device. All right, cool. So now we can say tick. All right. Without this function, your device is not connectable. Let's run it. We're gonna get errors, and we should see them here. So 48, 48, 48, all of those. So service had an error, characteristic had an error, and description had an error. And what that means is that it's out of memory. It doesn't have enough memory in the database itself. So what do we need? We need to define the services. So we added one service, and then we need to define the attributes. So the characteristic, for the definition of the characteristic, it takes two, one for definition and one for declaration, something like that. So it takes two. If you have notify, you have to add one more. Sorry, one more, right? And then if you add a descriptor, which we did, is the description, then you add one more. So now it's four. Here, this 44, what it means is 36 plus 8, which is the name of the default configuration that this one has. So that makes 44. But our description is 23 characters, right? The characteristic itself is it's 20 characters long. The notification requires to add two more. And then what else do we need? We also need the 30 of the description that we added to the characteristic. So we need all of that data to complete the database itself. And we also have to make sure that because we need 4 attributes, then we also need one for the service. So we have to make sure that we have 5 at least, right? Which we already do here. That's what the 5 is. I put the 5 there in anticipation of what I was going to need. So let's compile again, and we should get the service and the characteristic going. If we did it correctly, we should always get to we should also get the description as well. So let's see what it does. Okay, all zeros, right? So that means that if I open this up, we should see a name, which we do right here, right? And we have a service, just like what we had. And let me disconnect so we can see it as well. So we'll see the HM11 as soon as it updates. So here's the HM11. It has a name and advertising the service. We have the full name we decided to put on our device, and we're advertising the service. So let's go look at the HM11. It has the 16-bit ID, a name, the properties, and the ID of the characteristic. And here we have a read, listen, we have a write, and then we have 0 for a descriptor for the notified, and then we have another descriptor for the description, read, write without response, and notified. So now let's go look at our service. Any moment. All right, here we go. It's taking a while to update here, even though my phone already connected. So here it is. So
So there's the name, right? However, it doesn't have the full name, so we have to figure out what the deal is. But we do have a name. We have a 16-bit description or ID for the characteristic, and then no, this is the service, and this is the characteristic, and the properties should be identical as the other one. So let's wait for this to update. There it goes. So we have read, listen, and notify, right? And then we have write, and we have a 0, the one with the name, read, write without response, and notified. So let's go fix this part and see what the deal is with that one. So let me get out of it. And that's likely just what I think is happening is that it's not able to pick up this length because it's not a character, it's just that. And oh, I know why. It's because we didn't put this. So it's only picking the size of the actual type instead of the size of what's in it. So I'm gonna compile again. And as soon as this updates, we'll go and connect again, and we should see the name. All right, let's see. There it is. So that didn't do anything. Let's make a change here where instead of, oh, okay. Actually, I take that back. The mistake was here. I should be using the description one, not the ID, because the ID is 2, right? So that's what we need. Let's try again. I was picking the size from the wrong variable. All right, so it kicked me out because it's reloading the bin file. So let's see where that is, right here. Okay, there it is. Something went wrong, so it didn't like it, and we can look to see why it didn't like it when we bring it up here, and it's likely that it doesn't have enough memory. So let's compile again. Maybe my calculation was wrong. So we'll probably see out of an error because it doesn't have enough space to handle this stuff here. Actually, it is there. Everything is there. So 1, 2, 3. How long is it? 30. Let's see. Yeah. So that shouldn't be an issue. User command interface. We'll define it, but just for kicks, we're gonna add a little more space here just to make sure everything works. Let's see, everything should be there. But just in case, we'll add 2 more. By the way, you can increase the size very large. It's just the idea here is to keep it as small as possible, so you can run out of memory for your other functions. But same with with this stuff here, you can add a large number and see how that behaves. So let's go look at it again. Let's see, while it loads, let me verify my data here. All right, so the data is not taken for some reason. I have to go look at this thing and see why not. So if we go look at the database size and we look at the attribute records, it says that you need, so you need 2, this is for characteristics, right? Declaration and the value. So we have the value. Let me make sure that we do have it. So we have the 20 plus the 3, the 23, and then 20 for that one, for the value. And we also need 2. So that should be 22. for the declaration. So the characteristic is having a database minimum 2 attribute records needed, one for the characteristic declaration and one for the characteristic value. So that's 2. And on top of that, you also need it for the properties, right? Characteristic properties. In particular, it says if it has nullified, then you add 1. So that should be 3, right? So it was 22, so it should be 23. And what else? The characteristic has an extended, it doesn't have an extended property. Okay. There's nothing else here. Oh, I'm sorry. This is for the attribute record. So that's fine. Is this one the one I'm looking for? So this is what we're missing here. So in this one, it says that you need to. So if your characteristic is 16 bits, then you add 5 bytes, right? For the declaration, and if you want 128, then you add 19 bytes to that thing, in addition to the value length. So we have 20 plus 5 should be 25. And then we have other stuff here that says if the server configuration descriptor is added, or the client, right? So server or client, which we did. So that would be 2. So that would be a total of 7. And then what else? Extended, we don't have anything extended. So we need to have 27 here. I know I changed this one, but at a minimum, this should be 27. And we'll see what we get now. So let's wait till this thing starts connecting. Once this number starts changing, there it is. Now we have an active device. All right, so there it is. So now we have the username, the whole characteristic description, and everything else that goes with it, and is identical to the other one. So I'm gonna cut this video short because it's already an hour and 20 minutes, and upload this. I'll upload all the files to go with it, and the next video I'll add the actual functionality to send data back and forth. We are gonna add a second service. One specifically for AT commands and another one specifically for serial communication with the host on the other end. So this is how you you do a full Bluetooth advertising and services and characteristic descriptors. Not difficult, it's just a lot of coding. The most difficult part is the database definition and understanding what they're saying here, because a lot of the information is vague. To the point where if you're new to this, you wouldn't be able to make sense of it. Okay, so that's the video. I hope you like it. If you need any help, let me know. Everything else will be in the description, and enjoy.